So here we are at VRX 2018. I'm here with Jason Parks and Andreas Werner of Advanced Realtime Tracking. So Andreas is one of the leaders in the world in tracking research and has been developing this for quite some time. So Andreas, welcome.
Yeah, thank you.
So can you kind of go into just what you've seen over the years of tracking and to like where it is now versus where it was like 15, 20 years ago?
Okay, yes. I mean, ART has just grown up 1 year ago, so we are now 19 years in the business, and we started really with the beginning of the cave and VR environments in the automotive industry. That was our main start. So with the big VR systems building up in Volkswagen, Daimler, Audi, BMW, they all built up their VR systems in the end of the 80s. And they needed a reliable tracking that is precise, because you get seasick as soon as you move any way that you don't really move. And so these caves needed something precise in there, and that's where we came in with the optical tracking systems. Because everything before was a magnetic tracking, except with some exceptions, and that had a visible jitter that was not acceptable for real long-time work. You could work some minutes, but not an hour or two. And that's where we started and built our first cameras in that business, and then built up all the environment around. Clip-ons for targets, for special glasses, special devices like a finger tracking.
And did you start out doing passive tracking, or did you move into real-time right away? Or active tracking, excuse me.
We always worked with active and passive markers, but always with real-time tracking.
I see.
So we never had an offline tracker that analyzed the data afterwards. It was always online tracking, immediate data, because we really started with the virtual reality systems.
And like today, you're here demoing your latest system, which has a clip-on for the new VR Engineers headset, yes. And turns it from a 3 DOF headset into a 6 DOF headset.
Yes, that's one of the things we can do with multiple headsets. They all include nowadays an inertial sensor for the rotations. But if you want to work on large areas, then or at all want to work with 6 DOF tracking, so want to walk around an object, you need the 6 DOF position, and that is done by an external tracking system. In our case, with the cameras you see here, like the R-Track 5s on the left. But we also still work in the projection business, which you see one booth further with a small cave.
I see.
Excellent. Also, right now, we're all looking at the pamphlet for art. What got you involved in creating a handset with motion sensors?
That was simply a customer. That was a customer, and we can say it was Volkswagen. They started analyzing how to operate the dashboard, so finding whether you can easily operate all the switches and so on. And they started with gloves, and gloves are typically measured at the wrist of wrist of your hand. And then integrate all the movement to the fingertip. But for doing something like a NEF system, you want a millimeter precision for the fingertip. And so they came to us and say, we know that your system overall is that precise, but we need something that precise in the fingertip. And so we started a project with them to build a system that really measures the fingertip position. And that was the first step, not the one you see here.
And do you find other customers coming on and jumping on this? Is this something other
yes.
users want?
It's a well-sold system. There are more than 100 of these hands out there. And we recently added the step that you also get feedback when you touch something, because it was only giving the positions, and now it gives also a vibration under your finger when you touch a real object.
Oh, wow. So you've added haptics.
Fantastic.
That's very cool.
Yes. Yeah, that seems not that important when you do for reachability studies, but when you touch object in VR that you can't see because your hand is behind another object, then you don't even notice when you touch it. And so this way you can really notice that you touch it even if you don't see it.
And the main use case for art is manufacturing, and specifically the automotive industry. So does this allow you to basically put markers on any real thing and then have like an overlay on it?
Most applications are projected VR. So standard things like the seat bug, where you have a seat and try to operate a car, or visibility studies, maintenance studies, building studies, assembly studies are a big point, where companies simply take an engine, for instance, and try to assemble it in the virtual world before they ever build a prototype. And that is important because it really happens that they have all the machinery and finally find out that they can't assemble the part. And that really happens and is an extremely expensive thing to happen, because if they have already built the tools, then it's too late. They have built a big press forming sheet metal and find out that they can't build it together. And so they take a virtual model of everything and try to manually put everything together in VR before they build the tools.
I see. And the tracking allows them to work in VR with real parts.
Yes.
I see. That's cool.
Yeah, that is fantastic.
But not with real parts, with simulated parts.
Yeah, simulated parts, I
with
see.
Fully virtual parts.
Oh, okay.
And they model the physics behind that, so if they stick somewhere, they can't move it further in the virtual world. We can also put real parts into it and mix the real world and the artificial world. That's another application.
Have you seen that used yet?
Yes, pretty often, because they want to do the ergonomics, and then they have a real door, have a person with markers on the arms or on the full body, and try to, let's say, put the seal in, and find out whether the worker, after a while, will have a bad shoulder, because he always has to turn his arm around. So that's worker ergonomics is an important field. So they can really check that before they do the assembly, or when it's bad, they find out better to circumvent it. So we had a case where they really did a study, because in one place the workers always got a bad arm, and the only thing they had to do is put a step there, so he doesn't have to reach that high. So he works a little bit lower with his arm, and immediately the arm problems of the workers there were gone.
Oh wow! So that even has a healthcare application to it. Wow.
Now you mentioned a few uses for the accurate, reliable tracking. Now, what is one of your favorites?
Oh, I like the visibility studies, because it allows you to drive a car through a real city.
Oh yeah, okay,
but that's one of my favorites. I was in a cave driving it all the way through Munich, and I know Munich, of course, because it's close to where our office is, and I could drive. And they even simulated the driving dynamics of the car. So when you go fast to a curve, the car bends to the side.
Oh, that is so cool.
Oh, that's the future right there. Yeah.
Yes, and it's great for them, because they can put a tall person in, a smaller person in, and drive through the city
I see.
and make sure whether they can still look at the traffic lights.
Oh, yeah, that's like a very important thing, and I wouldn't think they'd have to consider.
Yeah.
Okay, wow.
Now, is that something that your company shares, or is that a demo that's ever at, for example, right now we are at VRX Immersive Enterprise. Is that something that would be shown here, or a similar
No, that's typically
event?
done by the customers themselves, and typically done with cars that haven't yet been built, so they would never share that.
Mm-hmm.
That's something internal. They all do this kind of simulations, but they all never do it with a car they already built.
All behind
they
closed
do it
doors.
with the next generation.
I see.
So our listeners would need to come with you business proposition before they can try driving around Munich.
See, it's the old word. We can show it to you, but then we have to kill you before you go out.
Lock and key, huh? Very nice.
Okay. Yeah. All right. And are there any other industries that you can think of that maybe it hasn't been applied to that you think it has a lot of use cases for?
In fact, there is one. The AEC, the building industry, is very far behind the automotive industry in what they do with virtual reality. They are just catching up a little bit with all these head-mounted devices, and you've seen some presentations here. But the big presentation rooms like caves, power walls, and so on, that could be used for presenting big projects. Of course, nobody would do that for the house next door. But if you want to apply for a project like a new railway station, which is some $1 billion, then for the presentation, you could get a giant presentation to the politicians and so on. They could really walk through there their new railway station and have the impression of the full field of view. And that is not done at the moment. They show videos, they show renderings, but virtual reality is more or less not done in that kind of presentation. And that's, I think, one of the big markets that could still work on that.
Is there any other things that you have as a product that we haven't covered yet?
Oh yes, one of our specialties here. That's a special camera. Just as a description, we have a camera that is only a small cylinder, 1.5 inch diameter and somewhat long. And you have projection environments that have projected ceiling and all walls. And so how to put a camera in there? You could hang a camera in there, but then you have always a big camera in your virtual reality. And so this way we drill only a small hole in a place and put the camera in from the back. So that gives you nearly invisible cameras in that virtual spaces.
And also, if any listeners would like to learn more, what would be the best way for them to reach you or reach your company?
Yeah, the easiest way is to go about our webpage. So www.ar-tracking.de or com, all is accepted. And yes, and there is all the information about us.
All right, this has been another episode. Thank you, Andreas, for being on the show. We'll see you in this reality.
And the next. Thank you so much for listening. We would like to keep sharing more about VR and AR with you, so please consider a few dollars to our Patreon, linked in the show notes. The Virtuality Podcast is produced by Jason Parks and music by Rachel Dazinski. This podcast is in collaboration with Boston VR and Boston AR. Monthly meetups and events can be found on meetup.com. You can also follow us on Twitter @VirtualityCast and learn more at our website, virtuality.show.